On August 5th, Meta finally walked into the AI coding agent arena. They shipped Muse Code, a terminal coding agent, running on a brand new model called Muse Spark 1.2. But the most interesting thing about this launch is not the feature list, it's the scoreboard Meta published themselves. Meta put out 5 benchmark charts. On 4 of them, Muse Spark 1.2 comes in second, and the model beating it is Claude from Anthropic. In this video, I'm not going to read you the press release. I went through all 5 official charts, zoomed in, and read every single bar. Then I checked them against the public leaderboard. Let's go through it properly. First, what it actually is. Muse Code is a coding agent that lives in your terminal. Meta describes it as taking on complete software engineering tasks. Planning the changes, writing the code, and then validating the results itself. Those 3 things chained together are what make it an agent rather than a chatbot that happens to know Python. Installing it is one command, a curl line that pulls Meta's install script and runs it. But note this up front, it's in beta, and it only supports macOS and Linux. The model underneath, Muse Spark 1.2, has a 1 million token context window, and it's multimodal. It accepts text, images, video, audio, and PDF documents. It's also a reasoning model, which means the tokens it burns while thinking get billed as output tokens. You can dial the effort up and down. Remember that, because it matters when we get to pricing. It's worth pausing on how crowded the space already is. Anthropic has Claude Code, OpenAI has Codex, there's Cursor on the editor side, Grok Build from XAI, and Google's anti-gravity CLI, which replaced Gemini CLI earlier this year. So Meta is not opening a new frontier here. It is arriving late to a market where the leaders already have millions of developers using their tools every week. That's the bar Muse Code has to clear. Now let's talk about the 3 design decisions that genuinely set it apart. These are the parts of the announcement I found actually interesting. Number 1, the event log. Every model call, every tool run, every approval, every file edit, all appended to a single local log as they happen. Meta uses 2 words for this: replay exact and restart safe. In plain English, the whole run can be replayed precisely, and after a crash, the agent picks up exactly where it stopped. That sounds boring until you've actually run a long agent task. The painful part is almost never that the model wrote bad code. It's that it died halfway through and you have no idea what it already did. Number 2, persistent async background agents. The usual pattern is that you spawn a subagent per task, it finishes, and you throw it away. In Muse Code, the background agents stay alive for the whole session. Meta's argument is that this avoids regathering the same context over and over and cuts down how much you have to steer it. Number 3, parallel subagents, each running in its own isolated Git worktree. This is Meta's own screenshot. 6 tasks running at once. 4 done, 2 still running, each with its own worktree path, none of them stepping on each other. Zuckerberg's line on this was, quote, "Your working copy is never touched." If you're the kind of developer who doesn't trust an AI near your files, that's a genuinely reassuring design. Next, the bundled skills. The first one is /plan. It turns whatever you asked for into a plan that you have to approve before anything happens. Here's the real output from Meta's own demo. A goal, the grounding it gathered from your codebase, key decisions, a work plan, how it intends to validate, and then 4 open questions aimed back at you. And the last line reads, approve, request changes, or cancel, meaning it hasn't touched a single line of your code yet. I rate that design highly. The second one is /grill. Its job is to stress test that plan, force it to find its own holes, and only move forward if the plan survives. But I have to flag a small nest here. Meta's own 2 official pages list different sets of skills. The research blog says plan, grill, and goal. The developer blog says plan, grilling, grill with docs, and taste, and the skill that actually appears in Meta's demo video is taste. So trust whatever your own install shows you, not the blog post. Okay, benchmarks. This is the part I really wanted to make this video for. Terminal Bench 2.1, Claude Opus 5 scores 86.7, Muse Spark 1.2 scores 82.9, second place. Deep SWE 1.1, Opus 5 gets 65.0, Muse Spark 1.2 gets 59.3. That's third, behind GPT 5.6 Tera at 64.8 as well. On GDP Val, which leans more toward general agent work, Opus 5 is at 1852 and Muse Spark 1.2 is at 1631, second again. But the awkward one is the 4th chart. It's called Meta Internal Coding Bench. Meta wrote the questions. Meta ran the grading. Opus 5 scores 79.4, Muse Spark 1.2 scores 70.6. On its own exam, in its own building, with its own marking scheme, it loses by almost 9 points. So does it win anything? Yes. Chart 5. MCP Atlas, which measures tool use. Muse Spark 1.2 takes 90.3 and first place. That result is genuinely impressive. And now here's the thing I only spotted after laying all 5 charts side by side. On the 4 charts it loses, the competition is only ever Opus 5 and GPT 5.6 Tera. On the one chart it wins, Claude Fable 5 and GPT 5.6 Sol are both in the lineup. I'm not calling that fraud, I'm calling it marketing. Every lab does some version of this, but once you've seen the pattern, you'll read everybody's benchmark charts a little more carefully. There's also a more fundamental problem. Those competitor scores were produced by Meta, running their rivals' models themselves. And Meta's own evaluation methodology document says it outright. They used an internal evaluation framework, it may not reflect these models' best performance, and it is not harness identical to the public leaderboard. So what does the public leaderboard say? On the official terminal benchboard, first place is Claude Fable 5 at 83.8, second is GPT 5.5 at 83.1. And Muse Spark 1.2 has no entry on that leaderboard at all. The only meta model on the entire board is the previous generation, Muse Spark 1.2.1, sitting 8th at 76.2. One more detail worth knowing. When 1.1 launched, Meta reported 80.0 for it. Independent verification came back at 76.2, and in this year's charts, 1.1 has quietly been relabeled as 76.2. Before we leave benchmarks, there is one demonstration in Meta's post that I think is more convincing than any of those bar charts. They pointed Muse code at GPU kernel optimization, specifically 2 attention kernels, KDA and MLA, running on NVIDIA Hopper hardware with an existing Triton implementation as the baseline. The number that matters is the shape of the run. More than 1,000 tool calls across a session lasting up to 24 hours, essentially unattended. That is a completely different claim from scoring well on a benchmark. A benchmark task takes minutes. Staying coherent on task and useful for a full day is the hard problem in this field right now. I do have to add a caveat. Meta did not publish speedup figures for that case study, so I can't tell you how much faster the kernels actually got. And reporting suggests that in this particular section, Muse Spark 1.2 comes out behind GPT 5.6 Sol. Now let's talk about money, because honestly, this is the part of the launch I find most worth discussing. The standard tier is $1.25 per million input tokens and $4.25 per million output tokens. For the market, that sits slightly below the middle. But Meta opened a second tier called Contributor, 10 cents per million in, 20 cents per million out. That is somewhere between 12 and 21 times cheaper. Why can it be that cheap? The answer is printed on the bottom row of Meta's own pricing table used to improve products. One column says yes, the other says no. In plain terms, if you pick the cheap column, your code, your prompts, and the model's output all become Meta's training data. That's not a conspiracy theory. It's the deal, written on the table, in Meta's own words. Clear and honest. You just have to decide whether it's a good trade for you. One commenter on Hacker News put it more bluntly. They're using a profitable ad business to undercut everyone and buy some relevance. And there is real context behind that. Meta still makes the overwhelming majority of its revenue from advertising. It has spent enormously on AI infrastructure, and it is under visible pressure to show that spending turning into a business. Selling developer tokens is one way to do that. Getting a fire hose of real-world coding data to train on is arguably the more valuable one. The contributor tier does both at the same time. For what it's worth, Meta does say it is now accepting requests for zero data retention on the standard tier. So if you're in an enterprise with compliance requirements, that path exists. It just isn't the 10-cent one. The model is also already listed on OpenRouter at the same standard pricing, which means you can route to it from tools you already use without installing Meta's agent at all. Speaking of the community, there's a gap here I find genuinely fascinating. Every media write-up focused on how clever the event log architecture is, but I went through more than 300 comments on Hacker News and almost nobody is discussing it. Developers care about exactly 2 things. What does it cost, and are you taking my code? Meta wanted to talk engineering. The community wanted to talk trust. To be fair though, I should give you the other side. Someone in that same thread pointed out that if you scroll a bit further down Meta's post, there is a chart that does include Sol. And another said, if it really is this close to Opus at a third of the price, that's actually pretty solid. Honestly, I agree with that one. So who should actually use this? Let's start with the most practical limitation. There is no Windows build. Meta ships macOS and Linux only, and there is no official statement about WSL anywhere. I searched again right before recording this, and I could not find a single community report of anyone testing it. So I'm not going to tell you WSL definitely works, and I'm not going to tell you it definitely doesn't. Nobody has verified it yet. By contrast, Claude Code runs natively on Windows. One more warning. At least one outlet reported that they got Muse code installed, but it refused to actually run until they attached a payment method. Beta is beta. Don't expect a polished product. So here's my recommendation. If you already work on large projects on macOS or Linux, go ahead and try it. It's one command, but I would not move your main workflow onto it yet. Let me close with what I actually think. The engineering in Muse code is real. The event log, the persistent agents, the isolated worktrees, all 3 of those solve problems that genuinely exist. But it's also a product with weights you cannot download, a login you cannot skip, and a cheapest tier that you pay for with your source code. Coming from the company that open-sourced Llama, that shift is worth noting. So whether you should use it isn't really a technical question, it's a values question. How much is your code worth to you? Answer that and you already know what to do. If this was useful, subscribe. I'll see you in the next one.